2 days ago. It passed Jupiter. 2 days ago. And no probe was sent. No mission was launched. Not even a single press conference was held. The most scientifically anomalous object ever recorded in human history slipped through Jupiter's gravitational sphere of influence with a margin of just 100,000 kilometers. And the world space agencies remained silent. What was found in the data before, during, and after that flyby has not appeared on the evening news. Some of it is buried in preprint archives. Some of it was quietly confirmed by a spacecraft that happened to be in the right place at the right time. And a new study released this week is changing everything we thought we knew about what this object is. What follows is built entirely on peer-reviewed research and mission data. No speculation without a source. And by the end, you will understand why a growing number of researchers are no longer describing 3IATLAS as a comet. Let me begin with the number that should have echoed across the world this week. 10 to 12 billion years old. That is the estimated age of 3IATLAS. According to a recent study published on the preprint server Research Square, based on data collected by the James Webb Space Telescope shortly after perihelion, the object is between 10 and 12 billion years old. The universe itself is about 13.8 billion years old. Our solar system is about 4.6 billion years old. That means this object is somewhere between 2.5 and 3 times older than Earth. It formed before our Sun existed. It formed before the planets of our solar system had any material to build from. It emerged during the early epoch of intense star formation within the Milky Way, when the galaxy was young, metal-poor, and violent. And for 10 billion years, it traveled through the void, across the galactic disk, through interstellar space where no telescope can reach. And then, precisely now, it arrived here. Using the James Webb Space Telescope, researchers measured the isotopic composition of 3IATLAS shortly after perihelion, the closest approach to the Sun. What they found was a higher concentration of deuterium, a heavier isotope of hydrogen, than in any comet ever studied, higher than any object in our solar system. They also found carbon isotopic ratios that fall completely outside the range of anything in our local cosmic neighborhood. These measurements act like a chemical birth certificate. And what that certificate reveals is this. This object formed at temperatures below 30 Kelvin, colder than the surface of Pluto, in an environment that was extremely metal-poor. Those conditions point directly to the early Milky Way, not a dark cloud in today's galactic disk. Not an object ejected from the outer solar system during planetary formation. The early galaxy. 10 to 12 billion years ago. Think about what that means for everything this object has witnessed during its journey. And there is something else in that study worth pausing on. The researchers concluded that 3IATLAS is not just ancient. It represents an entire class of objects. Planetesimals. The building blocks of planets. Ejected into interstellar space during the chaotic early stages of exoplanet formation. The implication is clear. There should be more of them. Objects with this age, this composition, this origin, drifting through the galaxy. And yet, none of them have passed through our solar system in recorded human history. So why this one? Why now? Why during the brief, almost microscopic window in cosmic time when we have telescopes powerful enough to detect it? What are the odds? By the time the James Webb Space Telescope was collecting that compositional data, 3IATLAS had already passed perihelion and was accelerating outward through the solar system toward Jupiter. But it was not alone. The European Space Agency's JUICE spacecraft, the Jupiter Icy Moons Explorer, was already on its way to Jupiter and was in position to observe 3IATLAS shortly after perihelion. The Janus camera aboard JUICE captured images of the interstellar object. Images showing a bright central coma and a long tail streaming into space. These were views from a spacecraft close enough to resolve details that ground-based telescopes, and even Hubble, could not fully capture. But what did those images truly show? ESA released a visual in a black and white frame from the Janus camera, showing the coma and the extended tail. That image was made public. But JUICE carries far more than a camera. It carries spectrometers, particle detectors, and magnetic field sensors. Instruments designed not just to capture images, but to measure chemical fingerprints, electromagnetic signatures, and the surrounding particle environment, a complete instrumental profile of whatever it observes. And that data, the data that would tell us not just what 3IATLAS looks like, but what it is, what it emits, what surrounds it at the particle level, has not been released. ESA confirmed the observation. They showed the image, but they have not described what the instruments actually measured. Ask yourself why. Now, let's turn to Jupiter, because what happened on March 16th, 2026, just 2 days ago, is something planetary scientists will be analyzing for years. 3IATLAS made its closest approach to Jupiter at a distance of 53.6 million kilometers. That may sound large, until you consider that Jupiter's Hill sphere, the region where its gravity dominates over the Sun, extends to about 53.5 million kilometers. That means the object passed roughly 100,000 kilometers inside that gravitational boundary. For scale, the entire solar system spans about 5 trillion kilometers. An object that has traveled for 10 billion years from interstellar space passed within 100,000 kilometers of Jupiter's gravitational edge. That is not random chance. That corresponds to a probability on the order of 1 in tens of thousands, assuming a purely random trajectory. But here is what makes this even more unsettling. The flyby was close enough for Jupiter to exert a measurable gravitational influence on its trajectory. Without capturing it, it passed through the outer fringes of the Hill sphere, used Jupiter's gravity, and continued accelerating outward. In orbital mechanics, there is a name for deliberately using a giant planet's gravity to gain speed without being captured. It is called a gravity assist, a slingshot. Human spacecraft use this all the time. Voyager used it. Cassini used it. New Horizons used it. These maneuvers are designed with extreme computational precision. And yet, 3IATLAS executed the same kind of maneuver on its outbound path, not inbound, where such an effect could be explained by approach geometry. Outbound, as it was leaving, as if it had somewhere to go, and needed to get there faster. So what trajectory is it on now? After that assist, it is moving away from the solar system at more than 60 kilometers per second. Where is it going? We cannot trace outbound paths forward through the galaxy the same way we trace inbound trajectories back to their origin. Interstellar space is not a map we can read in that direction with current instruments. But there is something in the trajectory data that almost no one is discussing. Throughout its passage through the inner solar system, scientists recorded significant non-gravitational accelerations, sideways forces that cannot be explained by solar radiation pressure or outgassing alone. An object influenced by unknown force vectors should leave on a disturbed trajectory. The outbound path should carry the imprint of those forces. A deviation, a distortion from the clean inbound geometry. But it does not. The exit vector is precise, as if whatever generated those forces applied them with control, and stopped applying them at exactly the right moment to maintain a specific targeted course. Now consider the part that was quietly confirmed this week. It connects to a mission proposal so serious that it has already been evaluated by an aerospace team. There is currently a concept under active consideration that proposes intercepting 3IATLAS before it becomes unreachable. The orbital mechanics team behind it says the mission is technically feasible. Not easy, but possible. Using a combination of solar sail propulsion, existing launch systems, and an extremely precise trajectory. The window is narrow. Every day that passes, the object moves farther away, and the delta V required to reach it increases. But the calculations have been done, and the conclusion is clear. It can still be done. Think about what that implies. The mission exists on paper. The hardware concept exists. The trajectory exists. The only thing missing is a decision. A decision that, as of now, no space agency has made publicly. There is one explanation for this: bureaucratic delay, budget cycles, procurement timelines, the slow machinery of large institutions. That explanation is real. Space missions do not launch in weeks. Under normal conditions, the process is slow and complex. But there is another possibility. In that version, someone inside one or more of these agencies reviewed the full instrument data from JUICE. Not just the image. The image was released, but the spectral data, the particle measurements, the electromagnetic signatures from a spacecraft specifically designed to analyze icy bodies in space, were not, and a decision was made. Not a scientific decision, but a political one. A calculation about what would happen if that data were fully released. Not an image, but a chemical and electromagnetic fingerprint, one that might not match any known natural object in any existing catalog, one that, if published in full, would raise questions for which no official response exists. The image was safe. 8 billion people looked at a faint blur of light and called it a comet. But the instrument data is not a blur. It is measurement. And that possibility is not paranoia. It is simply the second of two rational explanations for a silence that began at the exact moment a decision should have been made. And that moment was months ago. Now let me show you why the age of this object makes every other anomaly more significant. Not less. One of the earliest anomalies ever recorded was its chemical fingerprint. Before perihelion, the gas cloud surrounding 3IATLAS was found to contain nickel, in quantities exceeding iron, at ratios more consistent with industrial nickel alloys than with natural geological processes. In a typical comet, that would already be unusual. But in an object that is 10 billion years old, formed in a metal-poor early galaxy, it becomes far more difficult to explain. Because in the early Milky Way, heavy elements were rare. The first generations of stars had not yet enriched the interstellar medium through stellar nucleosynthesis. Iron was rare. Nickel was rare. Carbon was rare. So if 3IATLAS formed 10 billion years ago in a metal-poor environment, where did that nickel come from? There are only two possibilities. Either the nickel was not part of the original body, meaning it was introduced later from another source, or the assumption about its metal-poor origin is wrong. But both cannot be true at the same time. The isotope ratios clearly point to an early galaxy origin. The nickel concentrations contradict that origin. Something does not fit. The data is contradicting itself. And when data contradicts itself, it usually means there is something in the system that does not belong there. Something that was not part of the original structure. Now add another layer. Organic molecules. After perihelion, the object began releasing complex carbon-based compounds at an accelerating rate. Molecules associated with biological chemistry. For those molecules to survive 10 billion years of interstellar travel without being destroyed by cosmic radiation, They would have needed protection. At least 10 meters of shielding material. And that kind of shielding is not random. Cosmic rays arrive from all directions. To protect material over that timescale, the shielding must be nearly complete, covering almost every angle. That implies a shell, a continuous layer, something enclosing and protecting what lies inside. Not a random mixture of ice and rock, a structured containment. And then consider how those organics were released. They were emitted into space during perihelion at an increasing rate. As if something had been unlocked. As if the heat from the sun triggered a mechanism that had remained sealed for 10 billion years. So what can remain sealed for that long? Ice can. Under certain conditions. Rock can. Under certain conditions. But ice sublimates. Rock fractures. Over 10 billion years of thermal cycling. From temperatures near 3 Kelvin in deep space to the intense heating at perihelion. Maintaining a sealed and protected environment would require either extraordinary luck or deliberate design. And this leads to the deeper question beneath all of it. Not what we want to believe, but which explanation requires fewer assumptions? A natural origin, or something else? When you begin to count the assumptions needed to explain each anomaly, the trajectory, the rotational alignment, the symmetry of the jets, the nickel chemistry, the layered organics, the methane release sequence, the unusual polarization, the gravity-assist geometry at Jupiter, and the extraordinary age combined with preserved chemical integrity, you start to see the pattern. How many independent coincidences can exist in a single object at the same time? Avi Loeb, head of Harvard's Galileo project, proposed a framework for thinking about this. He calls it the Loeb classification scale. 0 represents a completely natural comet. 10 represents alien technology that could pose a significant threat. When 3IATLAS was first detected, he rated it a 4. But after the accumulated data, the age measurement from the James Webb Space Telescope, the JUICE observations, the Jupiter flyby geometry, and the post-perihelion anomalies, that assessment has shifted upward. He has not publicly stated a new number, and that silence is, in itself, a data point. What he has said is this: the cumulative weight of the post-perihelion anomalies, the age measurements, the isotopic profile, and the geometry of the Jupiter flyby pushes this object meaningfully toward the higher end of that scale. At a level of 4, he was outspoken. He wrote opinion pieces. He gave interviews. At whatever level it is now, he is careful. And that shift in tone, that change in public voice, is itself a data point. Now consider one detail about the Jupiter encounter that has received almost no attention in mainstream coverage. Jupiter has moons. 95 confirmed moons. Among them are the 4 Galilean moons: Io, Europa, Ganymede, and Callisto. Europa, in particular, is considered one of the most promising locations for extraterrestrial life within our solar system. Beneath its ice shell lies a global ocean of liquid water, sustained by internal heat and active chemistry. When 3IATLAS passed through the outer region of Jupiter's Hill sphere, it also moved through the extended gravitational and electromagnetic environment of Jupiter's entire moon system. It passed close enough to interact, even if only subtly, with the magnetic and tidal signatures of those moons. If this object carries any form of instrumentation, any kind of sensor or detector, then it passed directly through one of the most astrobiologically significant regions in the entire solar system. And it did so at a precise distance. Not captured, Not deflected. Observed. And then it left. I am not telling you what it is. I am showing you what it did. And what it could have measured as it moved through that region. The last image captured by the Hubble Space Telescope was taken on March 11th, 2026. Just 7 days ago. In that image, the object is already fading. It is dimming faster than initial models predicted. Whatever is happening to the reflective envelope around its nucleus, the coma, the dust cloud, the surrounding halo, is changing now that it has passed beyond Jupiter. As it moves deeper into the outer solar system, the environment grows colder. Sublimation slows. Outgassing decreases. For months, the object was surrounded by a cloud of complex organic molecules and water vapor. Now, it is beginning to go dark. It is shutting down. And if you were designing something to be highly visible while passing through the inner solar system, and then gradually become less detectable as it moves outward, this is exactly how it would behave. There is still time. Technically, the mission concept confirms it. A launch window still exists. A viable trajectory still exists. And somewhere right now, data from the JUICE spacecraft, from the James Webb Space Telescope, and from every radio array that tracked this object is sitting in databases, being processed, waiting to be analyzed and published. Months from now, the full story of 3IATLAS will begin to appear in peer-reviewed journals. But by then, the object itself will be gone. It will have passed Neptune, past Pluto, moved beyond the heliopause, returned to the interstellar medium where it spent 10 billion years before this encounter. We will have the data, but we will not have the object. We will have questions, and no second opportunity to answer them. And that is why the silence from space agencies matters. Not because silence proves anything, but because the decision not to act, not to launch, not even to publicly discuss the feasibility of an intercept mission, was made while all of this data was already known. That decision was made by people who had access to the same data you are seeing now. They saw the age, they saw the chemistry, they saw the geometry of the Jupiter flyby, they saw the JUICE observations, and officially, on the record, they said nothing. So ask yourself this: why would a civilization with multiple active deep space missions, with operational launch systems ready, and with peer-reviewed evidence of the most anomalous object ever observed, why would that civilization watch it leave and remain silent? That is a question you have to answer for yourself. I am only here to make sure you understand that it needs to be asked. 3IATLAS passed Jupiter on March 16th, 2026. It is already leaving. Within months, it will move beyond the reach of even our most powerful space telescopes. Now, to be clear, a natural explanation exists for each anomaly. When considered in isolation, the problem is not any single anomaly. The problem is that all of them exist together, in the same object, at the same time, reinforcing one another. At some point, the simplest explanation stops being an unusual comet and becomes something else. That threshold is not philosophical. It is numerical. And when you begin multiplying the probabilities of each anomaly occurring independently, the result quickly reaches a level that science does not comfortably classify as coincidence. The universe is about 13.8 billion years old. 3IATLAS is between 10 and 12 billion years old. Life on Earth is roughly 4 billion years old. If this object is not natural, then whatever created its time or launched it was already operating in this galaxy 6 to 8 billion years before Earth even existed. 6 to 8 billion years before there were humans to observe it. Consider what that implies. Consider the level of capability that could emerge over 6 to 8 billion years of continuous development. And then consider what an object of that age might be carrying. What it might be detecting, what it might be recording, and where that information might be going. We had one window, and that window closed 2 days ago. The data exists. The questions exist. The story of 3IATLAS is not finished. The data is still being processed. The papers are still being written. And piece by piece, that story will continue to emerge. But the object itself is already on its way back into interstellar space. And the silence that followed its departure may be the most important signal of all.